assignments that will be marked on your transcript. That is today during advisory. We will call for you to the meeting location at that time. Also, we have a representative here to go over and interpret ASVAB results for juniors and seniors. Mr. Willett will be taking care of that. When that ASVAB interpreter gets here today, we will call for seniors and then juniors. Today is National Wear Red Day and
the sixth graders.
This episode of Totally Awesome Book of Useless Information. Did you know that 66% of Americans admit to reading in the bathroom? Well, now you do.
You guys, we're about to do some word
IDs are part of the dress code and will need to be worn around your neck on a lanyard daily. All students and staff members should have one on at all times during the school day. Please, teachers at this time, scan the room and send students without an ID to the front office at this time. There will be random.
Do we need another one?
checks.
Okay, look, y'all can be my
If you do
calculator.
not have a lanyard or a plastic cover to cover your ID because it won't fit on a clip, there are the plastic sleeves for your IDs for 50 cents in the library, as well as lanyards for $2. Please remember that your barcode and your face has to be visible on your ID, and it cannot be defaced in any way. Have a great Friday.
Some crumbs on top of my barcode here. This is gonna end it right there. Okay, got the snacks out of my ID cover.
I was not mad at calculator. I don't know what.
Not gonna use this calculator. Let's see how strong it is. Is it still alive? They filled in some cushions there. Okay, those make a very different sound. I'm used to hearing the sound of these clunkers hitting the floor. I know that sound. I know the difference between the lid or the calculator, but that was kind of a bouncy thing. Anyway, okay, let's not all try it again just to see if they all sound like that. Okay, we got this far in our problem yesterday. We had two numbers. We knew the sum was 40, but we didn't know how to divvy up that 40, right? So we just said one of the numbers can be X. The other can be what you would get if you took 40 minus your X. That's a great way when you know a total or a sum, but you don't know the two parts. And we talked about, we wanted to use the same variable, X, for both of them. So we didn't have to go into some crazy system of equations. So then we were just starting to do something with our two numbers, which is what our quadratic is going to come from, because we want the product. And what does product mean? Ew, I did not like that. Anybody need a black pen in their life? I don't like the way this one feels. Okay, now everybody's going to shun the black pen. Okay, let's try again. And I don't like those. The best pens in the world. Okay, they're called Ink Joy, and they make me very happy. And they are triangular in shape. And apparently for left-handed people, these are the coolest. These are the most comfortable pens for left-handed, just in case you needed to know that piece of trivia. All right, product means multiply. And we're multiplying two numbers that happen to both be in terms of X. So at some point, an X is going to multiply times an X, and there's where this becomes quadratic. Okay, so we distributed, and then I'm guessing the bell rang, right? All right, I'm going to change this one to standard form this time, but you may decide you're okay with the linear term. Maybe you are okay with are you okay with the linear term being first and the quadratic term being second? Because if they want me to find, let's find a highlighter here, a maximum, if you see one of the two keywords, maximum or minimum, you need to think about the vertex. So if they're going to need me to find the vertex, and I'm in standard form, even if standard form is kind of backwards, but standard form as in there's no parentheses here, then in order to find the X value, I will need to use what formula to find that maximum point, or my vertex. How do I find the vertex? Actually, before I do that, there's one other little tidbit that you might want to get in the habit of doing on these problems so that you actually answer the right question. We know the maximum is the vertex, right? Okay. How do we know this vertex is going to be at the top of this parabola and is a maximum instead of at the bottom and is a minimum? Looking at this equation. Look at which one of these is your quadratic term? And so we know we've got a parabola that's going upside down if our quadratic term is negative. Do you agree with that? All right, that's important. Well, they aren't going to ask you for a minimum if it goes down forever. There is no minimum. So there's a big hint that, wow, I should be looking for a parabola that has a negative, so it has a maximum point. But I'm about to draw myself a rather fat ordered pair because I want to go to the problem and find out what the X and Y are talking about here. So looking at the problem, but also looking at the equation, okay, and any scratch work I've done, where have I put just a plain old X? Right here is where I define my plain old X. What's my plain old X? So in this problem, the first number of my two numbers is my plain old X. Plain old X is one of the numbers, okay? Now, what's the Y value when I never used a Y at all? Where would Y go in this equation if I put a Y there? It would be the M of X, right? And what am I finding here? How did I get this? The maximum product. So all the Y values are products of the two numbers. So check out the equation. To get this equation, I am multiplying the first number times the second number. And when I'm multiplying, I am getting the product. So if I actually graph this parabola, every point, the X value is the first number, but the Y value is the product of the two numbers. Now, the reason I'm going to make a deal out of making this ordered pair so you know what the X and Y are actually talking about is because some of the questions just need you to go as far as the X value. And some of the problems will ask you to go as far as the Y value. So finding a different highlighter, make sure this one isn't really dark. Okay. Yeah. Okay, this ordered pair. Okay, so I am wanting to know what the XY point are talking about on this graph. What are the XYs? So plain old X, and in some problems they will just tell you X is the whatever. They didn't tell me what X is. I decided that X would be my first number. So if I were to get any ordered pair off of this parabola, the X value is a number, a possible first number, okay? But then if I plug it into this formula, the formula is made up of multiplying the first number times the second number, because they said we want to get the maximum product. So we created an equation to find a bunch of different products. So remember yesterday where, I don't remember who was who. Did you have somebody, we were looking at 10 and 30, somebody gave me 10 and 30, somebody gave me 20 and 20, okay? What's the product of 10 times 30? 300. What's the product of 20 times 20? 400. You multiply the two numbers and you got two zeros. You got a calculator in front of y'all. Okay. Which one of those had a higher product? Okay. All right. What were some other possibilities? Somebody gave me 15 times 25 yesterday, right? Punch that in. Find out what that product is. 375. So one way we multiplied, we got 300. One pair of first and second numbers had a product of 375. One pair had a product of 400. So we have tons of different combinations, right? So the products means you take the two numbers, multiply them together, and we're getting different products. So these problems are out of all the different products, which one's the maximum? Okay, that makes sense? So in that case, I need to understand, what is the x value talking about? Because if I solve for x, which I'm gonna, well, never mind that. If I find the x value of the vertex, which is what these are about, I would like to know what I have found, okay? So I need my vertex, okay? And in this form, we're in standard form, right? So every problem that asks for maximum or minimum, I will start off by finding the x value of the vertex. And in this format, which formula will I use to find the x value of the vertex when there's no parentheses in my quadratic? Opposite of, everybody say it out loud. Opposite of, over. Expect that in these word problems. Now, y'all, B is your linear term, A is your quadratic, right? So very carefully, which one of these is the B value? Because this is not in order. Are we okay? Okay, so is it 40x or is it just 40? It's just the coefficient. So what is the opposite of my B value here? Negative 40. So occasionally, when you have to build the formula, they may not be in the order you used to. But we've done the quadratic formula 11 billion times, and we've called them constants and linear terms and quadratic terms. So are you able to, without having to rewrite this one more time in order, know that that's your B? And your A, what's your A going to be? Okay, well, 2 times your A, but what is the A itself? -1, but if I multiply 2 times your negative A, you're going to get, okay, could you possibly divide that without using your calculator? I get a 20. Okay, so what have I found there? The x value of my vertex, and what does that mean I have actually found? So in my little ordered pair, the x value of my vertex is the first number. Now, let's see what they want us to find, okay? Because they might say, what is the maximum product? If they ask what is that maximum product, I need to plug it in and get the product that goes with that, don't I? But that's not what they asked me. What did they ask me? Going for a different color highlighter. Some of my highlighters are so dark that they aren't highlighting. Oh, it does ask for the maximum product. Oh, heck. I didn't even read the question. I'm so busy looking for a highlighter. They want to know the maximum product. Without looking, I thought this problem asked for, what are the two numbers? That's what I thought this problem was going to say. I hadn't even finished reading it, but from my memory, I thought that's what this question asked. So would it be important to read the question part? Okay, because if it said, what are the two numbers? Well, the first one is x, which is 20, and the other one is 40 minus 20, which is also 20. So the two numbers are 20 and 20. But that's not what they're asking, is it? They ask, what is the maximum product? Well, I need to plug it in and find the y, don't I?
What does it mean at the beginning where it says five? Yeah, it says 5 with 2 numbers.
I think it wants to find both. I'm going to highlight that too. That's what I think. You know what I think? I think I'm going to look in my book. They may have asked you both. Let me just look. Or I may have added extra to what they had. This is number 48. Yeah, number 48. They stopped right there and didn't ask you what is the maximum product, I added that part to it when I typed it to make you see what you have to do. So we do have to find the two numbers, don't we? So our two numbers, the numbers are going to be, well, X is the first number, isn't it? 20. And what's the second number? 40 minus 20, 20. Oh, that's plural numbers, right? So that answers the question the book asked. But then I went a little further because sometimes they ask you, now that you know what gave you that maximum product, what is that maximum product? So I would probably just say the max, or you might say max product. What is that maximum product? And you might want to say 20 times 20, which equals what? Just in case you wanted your notes to know how you got a product. 400. Of the ones we just threw out a minute ago, that was the highest one we came up with, wasn't it? Okay, let's look at some more examples to get a little more used to the things you need to do. Sometimes they will just have the equation for you, but this was one where you had to create the equation. Okay, let's look at number 50. The revenue of a charter bus company depends on the number of unsold seats. If the revenue in dollars R of X is given by, and then they give you the equation, which happens to be quadratic, doesn't it? Looking at that equation, what do you know about that parabola? Opens down, which is probably why they are going to ask us for the maximum, right? Now, let's dig through and find out what X and R of X, they're using that instead of Y, are talking about. Right here, you see where it says R of X? What does it say right before it that R of X is talking about? This is, I'm going to put dollars, this is revenue. Revenue. Revenue is the amount of money you collect from the people, but it's not your profit. Okay? Revenue minus your expenses, that's your profit. Okay? So according to this, that revenue depends on some X value. What's the X value talking about? Okay, so this is the number of unsold seats. Now, I've looked at this problem now for about 8 years, over and over and over, maybe 7 years, over and over and over and over and over. I've seen this problem come up twice a year because I teach it in pre-cal and I teach it in my full-year college algebra. I don't know why, if you have some situations where you have more unsold seats, you get a higher revenue. It seems to me if you have unsold seats, you're making less money. Okay, but you know, I'm not a business analyst here. There's some factor that if you don't sell some seats, somehow that maxes out your revenue. I have no idea why, but we're just going to trust we're not here to do the business. We're here to do the math. We'll trust the math. They gave us a formula for which we can say, oh, thank you for writing the formula for me. Okay, so now, what are they wanting me to find in this problem? I think they may be looking for two things. What do they want us to do here? Find the number of unsold seats. How are we going to find the number of unsold seats? That's an X, right? And how do we find an X in standard form? Okay, but remember, this is an equation for the revenue. So this equation goes with this parabola, correct? Where will I find the highest revenue? So if I find the vertex, I find the max. Okay? So how do I find the x value of the vertex, which is where the max will be located? Now everybody say it. That sounded like a bunch of girl voices. Did you say it, Andrew? You don't know. You don't know. I don't think you don't know. Okay. I need you to hear it over and over and over so you start associating. You see some word problems on the test. The maximum means, I need the vertex. Vertex, if it's in standard form, opposite be over to right. Because you have bad memory. Does it not help you for me to beat things into your head? Yeah. All right. Things are in your head, right? Okay. So then they also want us to find the maximum revenue. So when they say find that maximum number of revenue, where's our revenue? That's going to be the y value, which means you have to plug the x in to this little formula that says, oh, you want to find a revenue? Here's a formula for finding that revenue. You've already found the x that gives you the max, right? Well, we're about to make that happen. So are you ready to make this happen? To find the x value in this formula, what would I plug in? What is the opposite of b? Negative 50. What is 2 times your a in this case? What? Okay, times 2. Okay. Can you do that one without a calculator, perhaps? Okay. Do they need me to say what that x value is? Was that part of the question? Was that one of the things I highlighted that I need from you? Find the number of unsold seats, which we said is going to be x. Have we found the number of unsold seats? We should write 25. Good. Having trouble with the letter O. And we should box that.
I think it's too simple.
I think we just need to, we're going to keep doing them and trying to keep getting used to what's going on. And then you've got some practice ones. All right. Now, was that all? Did I get to stop with just telling you how many seats? Okay. I can promise you, either on a review or a test or somewhere, there's some problems. There's a hot dog problem and there is a mosquito problem. Okay. In the hot dog problem, the number of hot dogs is the x value. In the mosquito problem, the number of mosquitoes is the x value. Okay. In some of those, they just ask you how many hot dogs. So you get to stop at x if you've taken the time to realize, oh, x is the hot dog. If it says how many mosquitoes, you get to stop at x. But I think, if they say how much profit do you make for your hot dogs, you need to plug it in and go further. I think the mosquitoes goes with rainfall. So anyway, I don't know. Or whoa, I'm back me up on that one. On the mosquito problem, the mosquitoes may be the y and the amount of rainfall may be the x. But the point is, make your ordered pair from what the story tells you, and if they tell you to stop at the x, you get to stop at the x. But they didn't tell me to stop at the x because they want the revenue, which is a y, right? So instead of a y, I'm going to say r of, and I want the r of 25, don't I? If I don't sell 25 seats, then I'll get a maximum revenue. So since they put it in function notation, let me just throw 25 at that function. So the function said the opposite of something squared plus 50 times something plus 5,000. And what's my something? 25 and another 25. So I could do that one in my head, but I'm not. What you get? A little bit of punch in, a little bit of type in, little parentheses here and there, maybe. Nobody wants to be the first one to cough up the answer because you're sure you punched it wrong, you have no confidence, you still punch it.
5,625.
She almost did exactly with you. 5,625 what? Sold seats? What? Revenues? Dollars. We got dollars. So dollars, say it again, 5,625. Have we answered all the questions they asked us? Okay. So we've got one more example, and it would hardly be advanced algebra if they didn't bring up this formula. Okay? Y'all, if an object is projected upward from ground level with an initial velocity of 32 feet per second, then its height in feet after t seconds is given by this. Do you remember in Algebra 2 talking about things going up and coming down and then making a parabola? Okay. If I track an object, and in this case, my object is starting at ground level. I don't even see an X in there, people. I don't see an X. Do you see an X? What letter are they using instead of X's here? Does it tell you what that T stands for? T is seconds. So why are they calling seconds T? It's a time. They're measuring time in seconds. If you shoot an object straight up into the air, if there's no wind or any other problems, the object's going to eventually get up to the point, turn around, and come back down. But we are tracking it over time. So if it's on the ground, at 0 seconds, it's on the ground. You shoot it up. Maybe it's a firework. I don't know. Maybe you are laying on the ground shooting a slingshot in the air, in which case you probably should roll over within a second or two because it's going to fall down and hit you in the head. Anyway, but whatever, that object, the object's going straight up and down. But if we keep track of it, what's this S of T talking about? Stop guessing. Read the words of the problem. What's the other thing that we're keeping track of in this problem? Height. Now, why the heck would they put an S with height? By the way, what are they measuring that height in? What units? Feet. Okay. Why would they use an S? Because in physics, the favorite variable for position of an object as it's moving, physics is like math in motion. Okay, so they track the movement of objects all the time. Their favorite variable for position of something that's moving its position is S. We looked it up once in calculus about 6 or 7 years ago because we were like, why do they use an S instead of a P of its position? And it's some German word that starts with an S. I don't speak German. I don't remember what it was. It's something like Schlag or something. I don't know, but it meant position. So there you go. That's why they used an S. Sometimes this formula is written with H of T, which makes way more sense for height, right? But not always. Okay, so we're going with S of T, which is talking about the height. If I track the height of an object over time, even though the object may be going straight up and down, as time goes by, as those seconds tick away, the object gets higher and higher and higher until, but a lot of times these objects don't just go forever. If you shoot a slingshot straight up in the air, again, step out of the way, are you likely to shoot it out of the atmosphere and go on forever? So tough, yes. No. What's going to happen to the rock that you just shot straight up in the air, which is really a bad idea? Why? Gravity. And as a little girl, I didn't know it was the word gravity. I thought it was the word gravity, that gravity reached up and pulled things out of the air. It gravitied it out of the air. I was a pretty cute kid, I must say. Anyway, so gravity is going to gravity it and pull it back down. Anything that is pulled to the Earth's surface or the surface of any planet by gravity, it picks up speed as it goes down. it makes a quadratic. It forms a quadratic because of the nature of gravity. So it slows down as it gets further and further up, and then it starts to speed up, and it will always, 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 always form a parabola naturally if you count it over time. Okay? Now, if you'd like a fun little example of this, or that, they have water fountains in this building somewhere. Right? Are the restrooms maybe? Okay, you push the button on the water fountain, okay? Does the water go up forever? No, what does it do? Picture that in your mind. It's a parabola. The water starts off going up at a pretty good speed. Gravity slows it down. It hits its maximum at its vertex, comes back down. It's a parabola. It's a parabola. You're dear to my heart. Okay. All the college algebra students will be playing with water fountain. Get out of my way, freshmen. I need to do some math. Okay. We don't say that to freshmen. I'm not encouraging bullying here. All right. You might say, excuse me, freshmen. I need to see a parabola here. All right. So anyway, as this object goes up and comes back down over time because of gravity, it becomes quadratic. It is always a quadratic. It's always a parabola. Okay. Tracking it over time makes a parabola. If you actually tilt your thing and it's not straight up, it'll make a parabola, the path. Okay. So with all that in mind, we got the formula. Thank you very much. What does it ask? What do we have to find? Find the number of seconds, which is going to be us finding our what value? X value. And then, what else do they ask us? Oh, which is going to be our what? Our Y value. Okay. Again, it may not have given you both of them. I might have. Oh, no, they actually gave you both of them. It wasn't just me. It was them. You can blame them. How are we going to find the X value of our vertex, which honestly is the T value of this vertex, right? Okay, and what is the opposite of B? Negative 32 over, what's 2 times your A? Not negative 2 this time. There's a negative in front of it. Negative 32. Oh, well, that's going to be tough. Punch that in your calculator. What's negative 32 divided by negative 32? 1. Okay, what have we found? The number of seconds. Do you see why creating an ordered pair to let you know what the X and Y values of the vertex are talking about is going to be very, very helpful in many, many ways? It's going to help you know what you have to answer. It's going to help you know how to answer it. 1, what? Second. Do I get to stop there? No, because they want to find the max, which is Y. Or you could think of it as S of T. What was our T that is going to give us the max? Oh, so the function rule was negative 16 times something squared plus 32 times something. And what am I plugging in? Oh, 1. Could you do it faster with or without the calculator here? Yeah, what's 1 square? Times this negative 16 is negative 16, right? What's 32 times 1? 32. Oh, you already told me the answer, didn't you? It was 16. 16 what? Gravities? Rockets? Feet? I'm not going to say 16 heights. Now we played with 3 of them. You got some odds in the book to play with. You got some problems on. Did I give you a worksheet yesterday? It's going to be due on Wednesday. You've been working on your major review? Okay. All right. that completes our 3.1 notes. Is there anything else on the back of that? Where are we for time? 4 minutes. Okay, let's just take a little look at what's happening tomorrow. I know with my regular Algebra 2 students last year in Little Cypress, we never, ever get to polynomial division, dividing polynomials, long division for polynomials, and synthetic division. So I know you've never seen that in your life.
I was looking at the book yesterday, and at the next lesson, and I was like, I have no idea what this is.
What about y'all? Does the term synthetic division ring a bell?
We did it, but I don't remember.
Yeah, well, every time I teach in college algebra, I teach it as if you've never learned it. Way back in Unit R, I'm going to pull back to Unit R. Remember that review unit? Way back in Unit R, I skipped a skill on purpose because you wouldn't need it until now. So they really wouldn't have done us much good for me to teach you the skill we need now in August. But back in, let's see, was it R.3, I think. R.3 is titled Polynomials. They had a whole section. Notice I marked it off and put hold. This is polynomial division. We didn't do it in August because I knew you wouldn't need it till January. All right, or February. We're running about a week behind here. You may have never done this in your life. Y'all may have, but I'm going to assume you've all completely forgotten it. I am going to teach you, starting Monday, polynomial long division and then synthetic division.
That looks like you just did GCX out. Is that
No, it's not going to work like so. We've done them. Okay, so this division is done when factoring won't take care of the problem. Okay, so on Monday I will be reviewing division that you learned in 5th grade, like I teach it to 5th graders, just in case you haven't done long division in a minute. Okay, give you a quick review of how I do division with 5th graders so that the long division will make sense. Because, I can only remember before I worked on my master's degree, math making me cry twice in my life. Okay? My master's degree, I cried a lot, like at least once a week. And my husband finally said, I used to worry when you started this and you were crying. And he said, I'm just not even worried about it. I'm just going to walk out of the room because I know you're going to figure it out. But, when math is hard, there's a process, all right? You look at the problem, you try it out, you panic, you cry, you pray, you sleep, and then you wait for the next morning, you know what to do. Okay, sometimes you need to eat a lot of M&Ms. But when I was in 3rd grade, I had a teacher who had a lot of health problems. I remember as a little old lady, I thought she was like 170, I'm not sure. But anyway, she had a lot of health problems, so we had a lot of substitute teachers. And one of the substitute teachers decided that in 3rd grade, we needed to be taught long division. You don't do that in 3rd grade. I'll tell you the rest of the story Monday. Remind me to tell you the rest of my story. All right. Goodbye, teenagers. Y'all have a good weekend. Put my calculators back. I'm gonna. Is this one of mine? Okay, I'm gonna grab this one. You will see me Monday. You can find out when I cried in math. Goodbye, teenagers. Okay. Over here. Escape. Bring it back. End stream.